All right, so I'm about to do my module 3 presentation. So I used SPSS, and I'll admit it was kind of shitty just because I couldn't get all the full features of R as far as the graphs and whatnot. But I'll make do with what I got. So MRC, multiple regression and correlation, it's test association. So we got a nice little formula here. Y equals B naught plus BX. So intercept plus slope plus E, which is the residual. And basically we get a line of best fit and gives us the smallest squared residual, which is saying that based on the line of best fit, the residual is going to be close as possible to that line, as close to zero. So basically the least squares. Tells us about how multiple independent variables impact the outcome variables and errors attributed to the model in this branch of the GLM. So for my study, I use Y1, X1, X2, and X3. So you get some nice little descriptive stats right here. This is where we really want to look. So we get the these unstandardized B's are going to be our betas, or what we're going to use for our parameters, which I'll explain later. So the constant is basically the y-intercept, and then these are three basically slopes for the different predictor variables. The standard error right here is basically how much these vary. So we want that to be low, so we're confident in our estimates. The T is an indicator of how the betas differ from zero. So the null hypothesis for this is that each beta is equal to zero. So based on these results right here, we failed to reject that null hypothesis, so they are not significantly different from zero. These are inversely related, so these low t's equal high significant or p-values. All right, so get into some assumptions. So these are pretty straightforward. We have a dependent variable that's continuous. We have at least two. You made us go above and beyond, so we have three independent variables. Independence of residuals. So this is important because we don't want a linear relationship between our variables. We want them to be unrelated. So for my diagnostics, I was given this Durbin-Watson, and a value of 2 indicates that the residuals are in fact independent. And so this 2 right here doesn't give me a reason to believe that I violated that assumption. So I'll move on. So then we want to look at the linear relationship between residuals and dependent variables. This isn't as pretty as R, but a line would go through right here, and I would say that this area might be a little bit problematic, but once again, I don't have those, that line that was produced in R book, so I might have, violated this assumption. But we can look at some partial correlations for each dependent variable, or for each independent variable, and these look pretty good. I don't see anything that would trigger me. Maybe these right here, but yeah. So homoscedasticity, I can't say it, but yeah, that one of the residuals. So we actually do have a line here. So with this one, we're just trying to say that the variance around the regression is the same for the predictive variables. And so up here, that is off a little bit, but it's offset by that. So I don't think that's any reason to believe that I violated that one. So that's the next one. This is a really, really important one, obviously. So based on the we have a lot of variables, and so when you have a lot of variables there, there's a chance that something's going to be correlated. And so what I found was that X1 and X3 were, pretty correlated, and you see that significance right there. So that's problematic. But to, further check that, we look at the collinearity statistics of the variance inflation factor. And, rule of thumb is that 1 indicates that, there's no multicollinearity. So these are really close to 1, so I don't have reason to believe that I violated this assumption. Outliers, leverage, and influential points. So we talked about Cook's distance and leverage in class. And so what I found for this is, this is the highest Cook's distance, which is pretty close to 1, which, could be very influential. But overall, the average for the Cook's distance was a 0.063. So outside of this 1 point, I would say that the data is behave nicely. The eighth and final assumption is normal distribution of residuals. So basically, we're looking at the variance around the regression is the same for the predicted variable.